So we're here in my shed to look at some 15th century navigational tools, the kind of tools that Columbus and other explorers used to navigate across the Atlantic for the first time. So we'll look at the tools that they used and also some of the mathematics that they used basically across the ocean. And you see how they did this 500 years ago and how it compares to modern things like GPS and all that easy things we have today. So here, to cross the Atlantic, I don't know where you're at sea anywhere, you only really need 5 basic tools. And this is what they have. So you have a travel spool that looks like this. We have a compass. We have an hourglass, which I actually stole out of my kid's cranium game. Those will be made of wood. We have what's called a leadline. This guy right here. And we have a quadrant, one of the most easily usable tools and used for a variety of different things. And scholars have been using these at least since probably the ancient Greeks. So I'm going to show you how you use these 5 tools to know where you're at anywhere in the Atlantic Ocean. Because again, when you're crossing the ocean, you have no land masses to base your navigation on anymore. So this is how you do stellar navigation to an extent, and basically trying to figure out what your longitude and latitude are at sea at any time. Let's look at the first tool. So the first thing we're going to talk about is how you figure out your latitude, or this is your north-south location on Earth. And you're going to use this instrument called the quadrant, right here. It's named the quadrant because it's 1/4 of a circle. And basically, as you rotate it, it has a line with a weight on it. So this is always going to fall straight down, wherever this is rotated. Now you might also notice 2 things sticking out the top of it, and these happen to have holes in it, okay? So the way that you use this is you're going to use it to look at the North Star when you're at sea, okay? So you can imagine, here's your quadrant, you have the 2 holes, you're going to look through the holes and line it up at some star. Get to the holes there. So you line it up at the North Star at sea, okay? So once you've sighted your star, you can look over here on this side. And so this tells you, that line with the weight on it tells you the angle between the horizon and the North Star. So this measures angular distances, okay? And that basically tells you what your latitude is on Earth. So for the mathematics of this, you can imagine, here's your Earth, okay? You have your poles and your equator like that, okay? So if you're at the North Pole, and here's a quadrant here, bring it back over. Here's your eyepieces again. You would be looking straight up at the North Star. And in this case, you would have 0 degrees on your quadrant, okay? And this is from right here on the pole. If you're at the equator, down here, you're going to be looking, the North Star is going to be right on the horizon. So you can imagine looking at it like this. Your line is telling you you're now at 90 degrees down here. Okay. So then anywhere in between those 2 extremes, so let's say you're halfway up, you'll be at 45 degrees. Maybe a little bit more north, maybe 25 degrees, a little bit more south, maybe 65 degrees. Okay. So what this tells you is, so if you have 0 degrees, you're at the North Pole. If you're at 90 degrees, you're at the equator. If you're at 45 degrees, then you're halfway between the 2. Okay? So this one tool tells you where you are at north and south on the Earth, anywhere on the Earth. So this gives you your north-south location or your latitude. Okay? So now you know how much above or below the equator you are on the surface of the Earth. And in the southern hemispheres, those southern stars you can use to basically achieve the same thing. But of course, all the Europeans are using the North Star to cross to the Americas at least. Okay, so that's how you figure out your north-south location. And scholars have known how to do this at least since the early Middle Ages, probably since the Greeks, how to do this. This isn't a very difficult thing to do. Okay, that's the easy part though. The difficult part is figuring out where you're at east-west, this way. And this is what's called your longitude. So this was very difficult to figure out. And in fact, they never actually figured out mathematically how to do this until the 1700s, and you get the invention of chronometers and clocks and Greenwich Mean Time. But this is the way that Columbus and other explorers tried to do this, try to figure out the east-west location. Okay, and to do that, you need 4 different instruments. So you need these four right here. Okay, so the first one we'll look at is something called the Leadline, which is this guy right here. So what we have is this will be often a little pouch with a weight attached to it. Basically just something that catches to the water. Okay, and you basically toss this over the side of the ship, and once you do, if your ship's moving, it's gonna pull line out. As it pulls more and more line out, one thing you might notice is that there's knots spaced out on the line. And there's a knot right there. Okay, so throughout the line, there's a whole bunch of knots all over the line, all spaced at the same distance. So what you're doing, it should have one guy on the side of the ship, so he throws out the lead line, and when he does so, he takes an hourglass, just like this, get the focus, and flips it over. Okay, and this starts the time going. And he's doing is the entire time that the hourglass is going, he's counting how many knots he sees pass by. Okay, so now you have a knots per time period. So let's say this is a 2-minute hourglass. Okay, that will give you knots per 2 minutes, or maybe 1 minute. I think this one was actually 1 minute. So maybe you have knots per minute, and that's basically giving you your speed of the ship. Okay, so now we can write here. We have knots per minute. Okay. And you're going to take one of these, maybe every 5 minutes, maybe every 10 minutes, something like that. So you're calculating your speed at regular intervals. Okay. Now the next thing we need to know is direction. We have a speed, we also need to know direction. So you're going to use 3 tools to calculate your direction. Okay. So way up in the front of the ship, you're basically going to take your dumbest sailor you have, because anybody can do this, and you're going to give him these 3 instruments. Okay. And what he's doing is he has the same hourglass, the same size hourglass that the other guy has. Okay, so in the same intervals, he's going to flip it over. Okay, and while that's flipped over, he's going to look at this guy. This is a compass, right? So no matter which way you move it, it always points north, right? So if your ship is moving this way, this would say that you are moving basically southwest. Okay, and if your ship changes direction, now we're heading west. Now we're heading south, something like that. Okay, there you go all the way on this way. Now we're heading north. Okay, so the compass just tells you what direction you're going in this time interval. So what he's going to do is, once all the time has passed, he's been watching this compass the whole time. He's going to figure out which direction have we been going for that entire elapsed time for the sand dial. Okay, so if it shifts slightly, he's just going to take the average of where it's been shifting. Okay. And that's where the travel spool comes in. Okay, so what we have here, I forgot the shadows here, is you have all the cardinal directions laid out here. Sorry, my sharp lights making shadows. So you have north at the top, north by east, north northeast, northeast by north, northeast, northeast by east, east northeast, east by north, and finally east. And goes all the way down, so you have all the east and then the south, and all the way over to the west. Okay, so you have all the cardinal directions here laid out. Okay, and we have a bunch of holes, and down here you have a bunch of pegs. So what do you think we're going to do? We're going to put pegs in the holes. Pretty simple tool. And what you have here is these pegs are all numbered. So you can see on the top they're numbered 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 over here. And also on the side over here. Okay. So what you do is, he's now, the hourglass is gone, he's been watching the compass, and now he knows what direction he's been going. Okay. So let's say they've been going west by south his whole way. So he's going to go to peg number 1. So you see this is column number 1 for the pegs. And take one of the 2, and you'll see that they're attached by a string. And he'll put it in west by north, west by south. Okay. Then we'll repeat this again, so maybe 5 minutes later he's going to take another measurement. Okay, do the same thing, figure out which direction they're going, go to peg number 2. Now they've moved a little bit, now maybe they're going west-northwest. So he'll put this in west-northwest. We've been going that way. Go back here, 5 minutes later, make a measurement again, come back to the travel spool, column 3. Okay, this time they shifted south a bit, now they're going southwest, right? Maybe the wind's changed a bit. So now they're going southwest. They've been going southwest that time. Okay, so what this does is give you a record of which directions you've been going and the orders in which that you've been going those directions. Okay, and you can, so the board allows you to record all the directions you've been going for maybe a 2-hour period. Okay, which is what the board is doing. It's just keeping a record, and you can reuse this over and over again. You don't have to write anything. All right. So then what they're gonna do is the guy who had the Leadline has his speed recordings, and now the Traverse board gives you direction recordings. So now you can go to the logbook, and you can put direction and speed and make a list. Right? So now maybe we have 3 knots per minute for speed, and you're going west by south. Okay? And then your next one is west, northwest at 2 knots per minute. Okay, and then maybe your next one is south, what do we have here? Southwest. Maybe you picked up speed, so you're going 5 knots per minute. Okay, so you basically make a big chart this way. What it can do is now you have your directions and your speeds. So once you have that, you can then plot out your course. So you start here in a known location, and you move this way, and then this way, and then maybe down here, and then maybe this way, and maybe that way. So you can plot out your course that way from this chart here. And what this can do from this, you can go, okay, here's my starting point, here's my ending point, and this gives you the total distance east and west that you've traveled. You can kind of confirm this by confirming your north-south locations here with the quadrants. Okay, am I really changing that much? And again, on a day-to-day basis, you're not going to measure this as much, but over maybe a couple of weeks, you will be able to use that north-south distance to confirm your calculations. So this is how they calculate the east-west direction. As you might imagine, this is not the most accurate way to do this. For one, calculating the speed with a Leadline, it'll give you an approximation, but this could be moving in the water too as you're going, so it's probably not going to give you an exact speed. And again, with the Traverse board, you're going to have very slight variations. You may be toggling maybe between these 2 directions the whole time, and you have to pick one of the 2 to say that that's where you're going. You're also only taking measurements maybe at 5-minute intervals or 10-minute intervals, and then averaging those together. But anyways, this is how they calculate the east-west direction. And this is why when you look at maps from the 1500s and 1600s, for example, the accuracy north-south is actually pretty good, but when they're drawing like coastlines or distances east and west, it's not very accurate because this is literally how they're doing it, and it's not going to be the most accurate method that you can do. But these are the tools and the mathematics that you would use to calculate where you are at sea at any given point. The other thing to know about this method is the only way that this works is if you know where you start from. So this is in relation to where you start from. So this is always a relative distance. So this won't tell you exactly where you're at on Earth anywhere. It will only tell you that if you know exactly what your starting point is, and then you can calculate how much you've traveled from that starting point. Okay, so you can't just pick this up halfway through your journey across the sea, or it won't mean anything. You have to do this the entire way from when you leave the coast, from a known location, and then travel from that point on. The north-south location, the quadrant, you can use this anywhere on Earth at any time, and it'll tell you exactly where you're at, north and south. So the last thing I want to talk about just a little bit is how to construct these instruments. So one thing about these, I made all of these myself, except for a compass and an hourglass. These are not overly difficult to construct. Cutting a circle is pretty easy. You can make a pretty easy jig to cut a circle for almost anything. I just cut this on the bandsaw, just drew it out. Again, with a set of dividers, you can see dividers in my other video on the cathedral videos. But basically all you need is 1/4 of a circle, cut out your angle here, straight edge here, something as eye sights. In my case, I left some wood on the end, drilled holes in them for eye sights. You could also just put in 2 nails and use 2 nails as eye sights. So that's pretty simple. And then just drawing these out. There's a number of methods to calculate what your angles are at any point. Certainly some old medieval ones. There's a lot of tricks to this. So it's actually not that hard. I probably just used a protractor doing mine. But in the Middle Ages, there's lots of easy ways. It's very easy, for example, to figure out where your 45 is. Once you figure out your 45, you can figure out your 22.5 pretty easy. Those different triangles you use to get your 30 and your 20-degree angles, and then you just kind of go from there to figure out the other ones. A few other things on this particular quadrant, and this is copied from one from the 1500s that I saw in the museum. These lines here are used to calculate, you can figure out what month you're in. There's 12 lines, and they're all labeled basically 1 through 12. And you can use these based on when the sun is rising and a few other things to figure out what month it is during the year. And then up here, the shadow box up here, you can actually use this by laying it kind of on its side and casting a shadow if your nail is sticking straight out. Basically the same way that you use a sundial. So this will tell you what time of day it is. So you can use a quadrant to tell you what time of day it is, what month of the year it is, so what your date is, and where you're at north and south anywhere on the earth. Just from this one tool, which is pretty cool. The lead line to construct, for me it's one piece of wood for the handle, attach two little triangles on either side, and it's just a dowel that rotates with a bunch of string on it. The most difficult part about this one was basically just going to, I used way too much string, so going through the whole string and tying knots along the string, and then actually winding it all up. It probably took me about 15 minutes just to wind all this code on here. And this is the second one I've made, actually. My first one was broken by my kids, who played with it way too much. So again, this is pretty easy, and this is just wood. There's nothing on this but wood and glue. There's no metal or anything. So again, that's pretty easy to construct in the Middle Ages. Hourglass, you just need someone who knows how to blow glass, which they're perfectly competent to do in the Middle Ages. Throw some sand in it, and you have an hourglass. Okay. And the actual timing, so this one is 30 seconds, I think, or 1 minute for cranium. The actual timing of the hourglass doesn't really matter as long as your hourglasses are consistent. That's the only thing that they have to calibrate. You need the time that they're measuring the speed to be the same of the time that you're measuring the distance. And that's the only calibration issues you need with the hourglass. So if they're 42 seconds an hourglass, that's perfectly fine. You're just going to take your measurements for 42 seconds each time you use the instrument. Maybe every 5 minutes. Okay. Your compass, they would have known how to use compasses since at least probably the 1200s, if not before that. Compasses became fairly common after a while. They had various different names, lodestones and a few other things. So compasses were actually quite common, certainly by the 1400s. And then the travel spool, this one probably took the longest to construct, but it's actually not very difficult at all. Pegs, just tying string to pegs, that doesn't take much time. Really took a lot of time was first drawing out your cardinal directions, so drawing all this stuff out. That certainly takes a while. But the thing that took the most time was just drilling the holes. So that was just about an hour and a half spent at the drill press, doing the same motion over and over again, drilling all these holes. And then I drew the lines on here based on a historical travel spool that I looked up from a museum website. So again, this is just laying out your lines, and again, it's pretty easy. So one thing, you see all of these are circles. So if you're doing this in the Middle Ages, basically start with basically making your right angle. You start in the middle, and then you just figure out some intervals. And again, you could do this with string, just like with the doing the arcs, for example. So you take a string, divide it in half, now you have half the distance. Divide that in half, now you have the half that distance. Divide that in half, now you have these two distances. Okay. So in that case, all you have to do is mark out these intervals on one of the lines with a piece of string, and then you're just doing circles. So you get your divider out, go from the center to that interval, mark a circle, mark a circle, mark a circle, mark a circle the whole way, and now you have circles going out. So now I know where all these dots are. And then just drawing lines from your cardinal direction. So you have a 45 coming in, and we have 3 more. So you just figure out what the mathematical ratios of that is, to basically figure out your lines out this way once you get your circles. But again, these are just circles of holes drilled around and around. And then once all the holes are drilled, I sanded off on my pencil lines, and then drew on in pen just actual cardinal lines from, and then labeled all of these. And these are just standard pegs. You can use a wooden dowel. They certainly know how to make wooden dowels back then, and string, which they certainly had. So all this, technically wise, it really doesn't take a lot of technical skill to make any of these instruments. like most things in the Middle Ages, they find simple ways to do complex things. And I think this is an example of that. None of these tools, for example, took me more than a couple hours to make, but they can really do a whole lot if you know a little bit of mathematics. I mean, literally, can you make a chart, a T-chart, with information on one side and the other, plot it out on a map, and that's all the mathematics you need. And that can tell you where you're at anywhere in the Atlantic at any time. And this is how Columbus and many of the other navigators and explorers were able to use a few simple tools and some simple mathematics to navigate across the ocean for the first time.